All right, we're now in our fifth section of chapter 2, and we're discussing acidic and basic solutions, pH, and buffers. And describing what is formed when water molecules dissociate is one of our learning objectives. Explaining the difference between an acid and a base. Defining pH and explain the relative pH values of both acids and bases. Explaining neutralization. And describing how the neutralization of both an acid and a base occur, and describing the action of a buffer. From a standpoint of water as a neutral solvent, water spontaneously dissociates to form ions. The bond between oxygen and hydrogen breaks apart spontaneously in the ratio of 1 to every 10 million ions per liter. Pretty significant ratio. Hydroxide ion, the OH group, is formed. In that sense, the hydrogen ion is also transferred to a second water molecule, hydronium ion, H3O plus, essentially. Now, equal numbers of positive hydrogen ions and negative hydroxyl ions are then produced, which helps water remain neutral. Now, an acid dissociates in water to produce a hydrogen ion and an anion, right? Then an anion being a negative charge. Acid, I should say, is a proton donor and increases the concentration of free hydrogen ions. The more dissociation of hydrogen ions makes a stronger acid, like hydrochloric acid in the stomach. Less dissociation of hydrogen ions is the case with weaker acids, like carbonic acid in the blood. In the blood, you don't want it to be as strong of an acid, whereas you would want that for breakdown in the stomach. As an example, substance A, or an acid in water, is a hydrogen ion plus an anion. Now, a base accepts a hydrogen ion when added to a solution. It's a proton acceptor. It decreases concentration of the free hydrogen ions. There's more absorption of hydrogen ions with stronger bases, and there's less absorption with weaker bases. A strong base being an ammonia or a bleach, and a weaker base being bicarbonate in blood. And the weaker the base or the weaker the acid, the more it's going to be less toxic to us. From a standpoint of in the presence of the body. If it's not in its, well, in many cases, in the case of stomach acid, in the stomach it's fine. If that were someplace else in the body, we'd have a problem with acid. Ammonia or bleach anywhere in the body in a significant level is going to be life-threatening, right? But bicarbonate is very normal in the blood because it's a weaker base. It's closer toward neutral pH of 7. Substance B, or a base in water, is basically a hydrogen ion, and that it's going to be absorbing that hydrogen ion. pH is a measure of hydrogen or hydrogen ions. It's the relative amount of the hydrogen ions in a solution. It ranges between 0 and 14. The pH of plain water, as I mentioned a moment ago, is 7. Water dissociates to produce 1, once again, in every 10 million of hydrogen ions and hydroxide ions per liter. That being said, the pH and the hydrogen ion concentration are inversely related. Okay, whereas the more you have increase in hydrogen ions, the more there's a decrease in pH. And the less hydrogen ions you have, the more there's an increase in pH, more towards alkaline or base. Okay. That being said, interpreting the pH scale, solutions with equal concentrations of hydrogen ions and hydroxide ions are neutral, have a pH of 7, water, right? Solutions with greater hydrogen ions than the hydroxide ions are acidic. They have a pH less than 7. Solutions with greater hydroxide ions than hydrogen ions are basic, or base, or alkaline, and their pH is going to be increasing above 7, okay? Moving higher and higher upward, the more base it is. That said, every movement from one increment to the next is a 10-fold change. So a pH of 6 has 10 times greater concentrations of hydrogen than pure water, even though it's only 1 level pH down as far as decrease. It's a big jump, right? That's why it's such a significant difference with even a minor change in pH, or partial hydrogen, right? pH. That said, in this case here, we're looking at an acid. We have the hydrogen ions are more than the hydroxide ions, increasing hydrogen ions, decreasing the pH, becoming more and more acidic. The base, you basically have decreasing hydrogen ions, increasing the pH, becoming more base-like, becoming more alkaline. Hydrochloric acid being basically one of the highest levels of acid, because it has to break down things in your stomach for digestion. It's very important that it be extremely strong, right? Whereas you could still be ingesting wine or even lemon juice, it's still a very high pH, but obviously you wouldn't want to take it in large amounts all at once. You could have some serious health issues, some possibly really major health issues in the very short term. Likewise, human blood is not that different from water, not too far off, 7.4 versus 7 from a pH standpoint. You start going higher and higher, more towards ammonia and bleach, and we're getting into some dangerous things for being present in the blood or in the substance of the body would not be a good thing. That said, neutralization is when an acid or base solution is returned to neutral pH, right? Neutralizing it. And acid is neutralized by adding base, and base is neutralized by adding acid. Not terribly surprising, right? And when you have an acid, you want to be decreasing the hydrogen ions, so you can actually move more towards base and actually, increase the pH. Whereas the other way is the case, if the base is too high, you want to actually add hydrogen ions from a standpoint of releasing them, and so you actually will decrease the pH and become more acidic to neutralize it to come back toward neutral pH. And why water is neutral? Because there's an equal number of hydrogen ions and hydroxide ions. Which type of substance releases hydrogen ions when added to water? Well, that's going to be essentially an acid. What's the general relationship of hydrogen ions and pH? Remember, as the hydrogen ions increase, it becomes more acidic. As they decrease, it becomes more base or alkaline. Why are buffers important? How do they function? Help maintain pH. A buffer will either add acid, or add hydrogen ions, in order to bring something more toward base. It'll actually be releasing them, or it'll be accepting them as opposed to donating them if we're trying to move it more toward an acid, okay, or a base, okay. And that is section 5. Only one more section for the short term before we go to the end, the remainder of chapter 2.